So the question is, when do we take our sample out of the beaker? And the answer is when the solvent level is less than a centimeter approximately from the top. This one's still got a little ways to go, but for the purpose of this video, I'm gonna start it a little early. You better have your pencil handy, because as you take it out, the solvent starts evaporating, and I need to know the height that the solvent moved. So I mark it immediately with a line. And notice that pretty soon, like seconds later, the solvent's below that line because it's evaporating. All right. So here we go. We're going to go on a road trip. I'm going to be wafting this like this on our road trip as we go to the lamp. And I don't have the lamp ready, so I'll pause. All right, so what we have here, you can see it either under the light or outside the light. Just the light helps. There's your ferrocene, definitely. Non-polar moves very high. Acetylferrocene is quite a bit more polar. It's there. The X values to the middle of the spots. There's X. Diacetyl is here. It moved very little. Now, if you had to guess, in this sample, you would say, I don't see ferrocene. I see acetylferrocene and diacetyl. How do I know that's diacetyl? It moved to the same height as this one. How do I know this is acetylferrocene? It moved to the height of this one. On my exam, definitely this is a darker spot here than here. I would guess that acetylferrocene is the major chemical in that mixture. And I would write that down for 3 points on my final. So you're going to do calculations for ferrocene. So the middle of the spot from the origin is X divided by Y, which is the solvent. That's called the partition coefficient. And here, did I call it partition coefficient? That's the wrong name. It's retention factor, RF. Is X over Y for ferrocene, X over Y for acetylferrocene, and the small x, which is only like a couple millimeters, over Y for diacetylferrocene. And that concludes what we need to do for this experiment.